Hi there, welcome to Group 28's presentation, Online Marketing Cards, TESCO Case Study. Team, I, Shuhong, will give you the introduction. Next, Gagi will talk about the data and the business question we tackle in this project. Pawan will then take over the exploratory data analysis. Before Page presents insights on RFM. Finally, Varun will talk about the prediction models and the business use case. The use of marketing content card is a very common online advertising method. Organizations nowadays grab clickstream data from websites in order to predict customers' preference based on the content they clicked on. TESCO employed various marketing content cards on its online shopping website. They gather data on customers who click on those marketing cards. Web mining can be of many types, like web content mining or web construction mining. Web usage mining involves identifying or discovering interesting usage patterns obtained from web logs. Those patterns enable you to understand the user's behavior. Clickstream analysis. Clickstream involves recording of parts of screen on which a computer user clicks during web browsing. The user action is logged on the servers as well as the browser, router, proxy server, or ad server. Clickstream analysis is useful for web activity analysis, software testing, marketing research, and for analyzing employee productivity.
TESCO dataset. We have data shared by TESCO on kaggle.com. This dataset contains fields associated to the customer like their gender, affluency, and county. It also has fields related to the spending patterns and transactions from different types of stores against each customer. The variables content_1 to content_9 are different marketing content cards. 1 means the customer clicked on the card. 0 means the customer viewed the card but didn't click it. NA means the user was never shown the card. We investigate the following through our analysis. First, RFM, calculate FM scores to understand customer value. Then business value of RFM, understanding the customer lifetime value. The prediction models, predict if a customer will click on a specific content card. And business value of prediction models, which is direct marketing. Exploratory data analysis. First, we look to visualize and explore the data set in order to obtain a clear understanding of the path that needs to be followed in analyzing our data to gain insights using RFM and prediction models. We investigate the following: the total expenditures by customers, total transactions by customers, and the expenditure by gender.
First, we read our dataset into Python using read_csv function from pandas library. Our data frame looks like this. The top 5 rows of the table. Exploratory data analysis. We create some calculated fields to explore the data further. We use aggregate function sum to aggregate the data. Fields include express total spend, direct total spend, petrol total spend, F&F total spend, extra total spend, superstore total spend, metro total spend. Now we plot the total spend of each store type above. These are the different values we plot. The plot looks like this. The most valuable channels are direct, extra and superstore. Calculating another field called total spend for further exploration. Now we group the customers by their IDs and calculate sum of their total expenditure. Plot of the top 10 customers with highest expenditure looks like this. We also grouped gender and aggregated their total expenditure. The pie chart here represents the percentage share of each gender in the total expenditure. Next, we calculate a field called total transactions as below. We aggregate the total transactions against group data of customer IDs. The top 10 customers with most transactions gives us the following plot.
RFM is a method used for analyzing customer value. It is commonly used in database marketing and direct marketing and has received attention in retail and professional services industries. Recency: how recently a customer has made a purchase. The frequency: how often a customer makes a purchase. Monetary value: how much money a customer spends on purchases.
We now look at how we can implement RFM scores in Python. In our data set, we don't have timestamps for purchases, and thus we cannot use this data set to calculate the recency part from RFM. However, we can calculate the frequency, monetary value, or FM score from this data set. Here we find the total spend. This gives the top 5 elements with total spend. Here is the data set with the field total transactions. Now we can create fields called rank percentile for both total spend and total transactions. Calculating average of both the percentiles. The average of the percentiles give us the FM rank percentile. Now, we will create FM scores based on the range of percentile of each record. The range is as follows. From 0 to zero point 0.1, FM score will be 1. From 0.1 to zero point 0.2, FM score will be 2. From 0.2 to zero point 0.3, the FM score will be 3, and so on till 10. Plotting the FM score for the first 5 customers. An FM score of 9 of customer 4 here represents that he or she is a much valuable customer than the other 4 customers, and thus TESCO should spend more time and effort on retention and growth of customer 4 in comparison to other customers in this chart. Next, we try and see if gender can be a differentiating factor in terms of being a valuable customer. But we don't really see any major difference in that respect. If we now go county wise, the sum of FM score from Greater London is much more than other counties, which means Greater London is a very valuable county for TESCO. In terms of affluency, medium affluency level group has much more FM score than the rest of the group. Medium affluency group is much more valuable, and thus TESCO should focus more on this customer segment.
We now want to create models to predict whether a customer will click on a particular marketing content card. Like all analytics projects, we go through steps of data pre-processing, building and fitting the model, and finally testing the model's performance metrics. First, we import the data into Python. We then find a statistical summary of our data. Now we create a subset of the data containing only marketing card 1. We can later similarly work on other cards. For now, we work on card 1. We drop all NA values from the column content underscore 1, as NA values mean the card was not shown to the customer and thus will not be relevant to our model. We then check for any missing values. In this case, there are none. Checking the data types of the variables. We need to change the data type of content underscore 1 to integer. There are 3 categorical variables in this data: gender, affluency, and county. We must convert the categorical data into numerical before we can run our models on it. For gender, we use one hot encoding mechanism. For affluency, we use label encoding. And for county also, we use label encoding mechanism. Next, we need to divide the dataset into input and output variables. The output variable in this case is content underscore 1, while the input variables are rest of the columns. To fit our model, we need to split the data into train and test sets. Here we divide it in the ratio of 70:30. We then train a decision tree model on the training data and predict on the test data. The plot of the model looks like this. The confusion matrix is calculated as follows, while finally the classification report generates values such as accuracy and precision of the model. In this case, the precision is 0.99 and the accuracy is 0.97 for our decision tree model. The previous set of steps were all to predict if a new customer will click on content card 1. What if we want to predict for other content cards like content card 2 or content card 9? We cannot write the code again and again for each content card. We thus created classes and functions to tackle this issue. The class here will perform all the data pre-processing tasks from reading to splitting the data in one go. Another class was built to handle 3 different models: decision trees, neural networks, and ensemble random forests. This class can be called after processing data to build models. Next, we built a class to handle the confusion matrix and classification reports of our models. This function here is used to call the class data preprocessing. We just need to pass the content card name to get processed data. Here we are passing content underscore 8 and we get split dataset. This function is used to call all the model class. Again, just pass the content card name to build models on the data. Here we are passing content underscore 4 and we get the output for that model. This function will call all classes and functions to perform all the tasks of data mining from pre-processing to final classification report. We just need to specify the content card name in the parameters. In this case, that is content underscore 4. Finally, we have used all the variables in our models currently. In future, we can use principal component analysis to reduce the dimensions. Currently, we have 17 input variables and we can reduce them to up to 10 variables without losing 96% of the variance of data if we use first 10 principal components. Conclusion: business use case. RFM scores can be used to understand which customers are more valuable. TESCO can then employ more resources in retaining and growing these customers. RFM score can also be used to understand which segments and counties are more profitable, and thus help TESCO in identifying local strategies for such counties and targeted strategies for such segments. Based on the output from the classification models, TESCO can identify the customers to whom a particular card should be shown and to whom it should not be. Indirectly, we are identifying targets for direct marketing measures.